Good day, everyone. How we're doing? All right. So, welcome to my channel once again. This is a follow-up video on the last video I posted on the introduction to what redox reaction. So, this lecture is dedicated to just solving past questions on the topic. Let's just get right at it. The first example we have here is what? We're given a reaction, and then the question says the reducing agent in the reaction is dash. Okay, so if you want to solve a problem like this in your exam, that's what you do. Let's write our equation. We have 2FeCl2 plus Cl2. Then we have 2FeCl3. Now, firstly, you need to identify in each of this reactant. We have this reactant and this reactant. The central elements here I can analyze for a change in oxidation state is ion. Chlorine, most times, its oxidation state in the binary compound of chlorine is always -1. Binary compound means anytime you say chlorine together with just one other element, the oxidation number of chlorine is always -1. So chlorine will be -1 here. This is also a binary compound. Chlorine is also -1 here. Okay, when chlorine is on its own, when it's not together with any different element, the oxidation number of chlorine is 0. Okay, the oxidation number of this chlorine here is -1. The oxidation number of this chlorine is -1. So automatically we have seen that what? For chlorine, we are noticing that what? The oxidation number of chlorine has changed from 0 to -1. From 0 to -1. Let's think about that. It means what? Now the oxidation number of chlorine was reduced. So the substance that is reduced is chlorine. So if I draw this arrow, this becomes our reduction. Why? Because the oxidation number reduced from 0 to -1. And remember the rule we're following in the previous video. I told you the substance that is reduced is usually your oxidizing agent. But the question is asking us for the reducing agent. So without even thinking that much, we already know that if this is our oxidizing agent, the other elements, the other species there will be your what? Your reducing agent. But then I would also explain why this is the reducing agent. So in your exam, once you are able to identify, let's say, the oxidizing agent, just know that the next species, your what? Reducing agent. But for the sake of explanation, I'm going to explain why this is actually the reducing agent. Now, looking at ion, I have not written the oxidation state of ion now. The oxidation state of ion here, if you calculate it, is going to be +2. Ion will be +2. Yeah. How did I know? From the rule we learned in the previous video, the oxidation state of ion we don't know. We take it, let's say Fe plus. The oxidation state of chlorine now is -1, which is 2 times -1 should be equal to 0. So you have Fe -2 is equal to 0. So you have Fe to be equal to +2 when you carry this over. So ion is +2 over here. The oxidation state of ion here, without even calculating, is going to be +3. All right. From the knowledge of formulas, you could just infer that this subscript that is under your chlorine here actually came from ion. That's another way to go about it. But I don't want to go into that. Just do your calculation, perform your calculation. Ion, we don't know. So I'll say ion added to, we have 3 chlorine there, which is 3 times -1 equal to 0. So you have ion -3 equal to 0. Carry -3 over, ion become +3. Now, what do you notice about ion now? We can now say that what? The oxidation state of ion now, in the reactant side, we have ion 2. In the product side, we are having ion 3. So we can see from the change in oxidation number is from 2 to 3. So that's increment. Remember, for the oxidation number of something to increase, of an element to increase, it means that element actually lost electron. And oxidation is defined as loss of electron. So therefore, if I draw an arrow from this down to this arrow represents the arrow for oxidation. Oxidation process always leads to increase in what? So this is oxidation, in the oxidation number of an element. So the substance that is oxidized is your reducing agent. So in this question, our correct option becomes what now? A. Is it A, not A? Okay, yes, it's A. Iron 2 chloride becomes our what? Reducing agent. Let's go to the second example without wasting time. All right, now let's look at the second example here. We're given a reaction, then the question says which of the substance serves as the oxidizing agent. So the same analysis you carry out, okay? So manganese is a transition element, and we know transition elements have varying oxidation state. So I would draw an arrow from this to this. So the central elements there should be manganese. Of course, oxygen most times oxygen is always -2, except in peroxide, and this is not a peroxide. So we're interested in knowing the oxidation state of manganese here. The oxidation state of manganese is already showing here as +2, but the oxidation state of manganese here is unknown. If you know the name of this compound, this is tetraoxomanganate 7 ion, since it's carrying a charge. It's not a compound, it's an ion. Tetraoxomanganate 7. So without any form of calculation, I already know that the oxidation state of manganese here will be +7. All right. But for the sake of understanding, let's calculate it out. How did we get this +7? So manganese, we don't know. I would say Mn added to the oxidation state of oxygen is -2, and we have 4 oxygen. 4 times -2. In my previous video, you always equate to the charge, and the charge there is -1. There's an invisible one there. So if you should open your bracket, you have Mn -8 equal to -1. So you have Mn will be equal to -1 plus 8, which is +7. So we now know that manganese here is +7, whereas manganese here is showing us a charge of what? Showing us a charge of 2. So from manganese 7 plus transitions to manganese 2 plus. So you ask yourself, is this an increase or a decrease? Of course, it's a decrease. So it means that what? This compound is being reduced. This compound is being reduced. And the substance that is reduced, according to our rule, is what? Let's say reduction. These are reduction process. The substance being reduced, which is this substance, becomes your oxidizing agent. So the answer to this question is going to be what now? D. So let's also analyze, just for explanation's sake. The oxidation state of chlorine here is what? Is -1. Okay? Take note, when you are doing your analysis, you are not making use of the coefficients at the back. You are just making use of the species themselves. Forget about the 10, forget about the 2. All right? So the oxidation state of chlorine here is what? -1. So we have Cl- transitioning to just Cl2. When chlorine is on its own in the molecular form, you should know the oxidation state is 0. So from -1 to 0, that is an increment. So it means the oxidation state of what now? Chlorine increased from -1 to 0. So that substance whose oxidation state increase, okay, is your reducing agent. So this is your reducing agent. Now, why did it increase? Because what? This substance now did what? Lose electron. When you lose electron, your oxidation state will increase. And loss of electron is known as what? Oxidation. So if I were to draw my arrow from chlorine transitioning to this, that is your what? Oxidation process. And the oxidation process, the substance that is oxidized, is your reducing agent. But the question is interested in our what? Oxidizing agent, which is this. So this becomes your correct answer. We'll move on to the next example. All right, now let's look at this number 3 question. Says, which of the following is not a redox reaction? Good. Now, how do you know a redox reaction? Simple. You inspect each of the option. Any of this option in which the oxidation state of the elements involved did not change. Once there is no change in oxidation state, such a reaction is not a redox reaction. Redox reactions are what? Characterized by a change in the oxidation state of some of the elements that are present in the reaction. So let's analyze each of the options. Let's start with option A. If you are good with your IUPAC nomenclature, which is the name of compounds, the name of this compound is what? Diazonitrate 3 acid. So from that name, without performing calculations in your exam, diazone-93, it means if I'm to calculate the oxidation state of nitrogen here, it's going to be 3. So let's calculate it. Remember, you're not working with the numbers at the back. So HNO3, remember hydrogen, HNO2. So hydrogen is 1, remember in acid plus 1. Nitrogen we're looking for. Oxygen is 2 times minus 2, then equal to 0. For a compound, the charge is 0. We learned this in the previous class. So you have 1 plus N, then minus 4 equal to 0. So N becomes minus 1 plus 4, which gives you plus 3. So nitrogen here is having a charge of what now? Plus 3. So we have plus 3 for nitrogen over here. Now let's look at nitrogen on this other end. The name of this compound should be nitrogen 2 oxide. So if you calculate the oxidation number of nitrogen here, it's going to be plus 2. If you, without even doing calculation, you know oxygen carries a charge of minus 2. Since the total charge in a compound must be 0, automatically it means this nitrogen here have to be what? Plus 2. Without, you can still perform the same calculation, you will have the same answer, plus 2. So it means the oxidation number of nitrogen actually changed from plus 3 to plus 2. So this is a redox reaction. We take that. We move on to the next. Let's look at zinc. The oxidation number of zinc is 0. When an element is on its own in the free state, in the atomic form, the oxidation state is 0. Now let's look at zinc over here. The oxidation state of zinc is going to be plus 2. How did I know? SO4 is a radical that you should know that SO4 carries a charge of minus 2. Since the total charge in a compound must be 0, it means the charge here have to be plus 2 for zinc. So it means that in a compound, the total negative charge must be equal to the total positive charge for the total charge of the compound to be 0. This is just a short approach to tackling the problem. You can still perform the same calculation like we always do in this compound, and then you are going to find out that yes, that is the case. So it means that the oxidation number of zinc changed from 0 to what? To plus 2 over here. So it means this also is a redox reaction. Now, if you look at this compound now, this is calcium. This is triazocarbonate 4 radical. Now, of course, this 2 you are seeing as a subscript is actually coming from calcium. So that tells us that the charge of calcium there is actually plus 2. So calcium is plus 2 over here. And then the subscript under this is 1. So it means this bracket here, the total charge of this radical have to be minus 1. But remember that you have a 2 here. So if you use this 2 to multiply this minus 1, we have a total charge of what? Minus 2 over there. So the main point is calcium is plus 2 here. And even at this point, yes, CO3 carries a charge of minus 2. So calcium will also carry a charge of plus 2 over here. Because the total charge, when you add them, the answer should be 0. So nothing happens to the oxidation state of calcium. What about carbon? If you are to calculate the oxidation state of carbon now, you are going to discover that in this place, carbon is 4. So let's calculate it and actually see. So for Ca bracket HCO3, we have that calcium is plus 2. Okay, plus there's a number here. This number here affects the whole of the bracket. So you write the subscript first. Hydrogen is carrying a charge of plus 1, like we know. Then plus carbon is what we're trying to know. And then we have 3 oxygen. So let's solve for carbon together. So we're going to have that this would be equal to 2 plus 2 into 1. Then plus C. Plus times minus is minus 6. So we're going to have that this will be equal to 0. Remember, you are equating all of this to 0. This is 0, you equate to 0. So we are going to have 2 plus 2 into 1 minus 6 will give you minus 5 plus C. All right, equal to 0. So from here, we can say 2, open up your bracket, that will give me minus 10, then plus 2C equal to 0. So 2 minus 10 will give you minus 8 plus 2c equal to 0. So you have 2c will be equal to carry minus 8 over, you have 8. So by the time you divide both sides, c becomes 8 over 2, which is 4, plus 4. So the oxidation state of carbon here is plus 4. If you perform the same calculation and you find out the oxidation state of carbon here, you also get plus 4. Of course, hydrogen is plus 1. Hydrogen is plus 1 here. Oxygen is minus 2 over here. Oxygen is also minus 2. This is carbon 4 oxide, CO2. So carbon is also 4 here. So this clearly is not a redox reaction. That becomes the answer to your problem. This is a redox reaction. Why is it a redox reaction? The oxidation state of iron here, since iron, oxygen carries minus 2, so iron will carry plus 2 for the total charge to be 0. So in this case now, this 3 you are seeing here is actually coming from iron. So I can clearly see that iron is carrying a charge of plus 3 over here. This 2 you are seeing here is clearly coming from oxygen. So oxygen is carrying a charge of 2 minus, remember. In case you are wondering why are they not the same, they are actually the same because remember you have 2 iron here. So 2 times plus 3 is plus 6. 3 times minus 2 is minus 6. So this is also a redox reaction. So the only reaction here that is not a redox reaction is this. So that becomes your answer. We move on to the next question. All right. Now, we'll look at this problem together. We're given an equation that is said in the reaction above, the products give A, a purple solution, B, a purple precipitate, C, a colorless precipitate, D, a colorless solution. Now, what do you do in this case? Let's focus on the product because the question is talking about the product. Now, remember that transition ions normally produce what? Colored solutions or colored compounds in solutions rather. So the transition metal in the product part of this equation is just manganese. So the first thing I should be doing as a student is to calculate the oxidation state of manganese here. I advise you all can perform the calculation like I have done in previous example. But from experience, XO4 usually carry a charge of what? 2 minus. Since the total charge in the compound must be 0, it means manganese is definitely plus 2 here if you should perform the calculation. So in my previous video, we learned that what manganese 2 plus ions, manganese 2 plus ion is actually a colorless. It forms the salt of this particular ion is usually colorless in solution. So if this reaction should occur and this product is formed, we don't expect to see any color because manganese 2 plus is not a transition ion. It forms a colorless solution. So the correct answer is going to be what? Colorless solution, option D. Now, I know someone would say, this also have colorless in it, but why not this answer? The word precipitate means the state of that substance. Assuming what you see here is solid, if this was to be solid S, this would have been the answer. It means that what? This solid is insoluble in the aqueous medium where the reaction is occurring. Hence, we call it a precipitate. But since we don't have a solid in this case, this compound, the wrote aqueous, so it means it's actually dissolved. So it will give us a clear, colorless what? Solution. So the correct answer for this question would be what? Option D. Now, I'm going to end the video here. Please, if you have any question, area of concern, drop it in the comment section. I would attend to it. And then you should know that under the subject of redox reaction, these are the type of questions you would see. 1, you would be asked to calculate the oxidation number of elements in given compounds or radical. 2, you would be told to identify the substance that is being oxidized or reduced in a particular reaction, which I have explained how you do. 3, you would be asked to identify your oxidizing agent and what? Reducing agent in a particular reaction, which we've also done. Also, you would be asked to identify from a list of options which of those option is a redox reaction or which of them is not a redox reaction. So that we did in the previous example. Redox reactions are characterized by a change in the oxidation number of some of the elements that are involved in the reaction. If there is no change in oxidation number, then that is not a redox reaction. Then finally, you will be asked questions regarding balancing of redox reaction, where they would ask you to calculate the number of electrons that should be added to either the product side or the reactant side to balance the charges in that reaction. That we've not done. We're going to create a video rather to tackle that part of redox reaction, which is balancing of what? Redox reaction. Watch out for my next video. In the next video, we're going to treat how to balance redox reaction. If you have any problem in the topic so far, if you have any question whatsoever, please drop it in the comment section. If you found this video helpful and insightful, please ensure to subscribe, like, and then share to your friends if you haven't done so. I'll see you in my next class rather. Thank you and God bless you.